How much is the mass in gram? The mass in gram is 44. What about the molar mass of a methyl propanoid? So molar mass of a methyl propanoid is, you have 1, 2, 3, 4 carbon atoms are there. So it will be 12 multiplied by 4. Plus hydrogen is 3, 4, 5, 6, 7, 8. So 1 multiplied by 8. And oxygen is 2, 1 is 16 multiplied by 2. This is not the mock, this is just a question student have sent. So 12, because 1, 2, 3, 4 carbon atoms are there. So 12 multiplied by 4, that is equals to 48. Plus hydrogen 3, 4, 5, 6, 7, 8 are there. So this will be 8. And plus oxygen is, there are 2 oxygens. So 16 multiplied by 2, it will be 32. So 32 plus 8 makes 40, and 40 plus 48, it will make 88. So 44 divided by 88, how many moles I will get? I will get 0.5 moles of this compound, methyl propanoid. Okay. Now, according to this, if I have a methyl, because I need the number of hydrogen atoms. So I will first find this is the moles of this compound, methyl propanoid. And if I compare the ratio of a methyl propanoid and hydrogen, in one molecule of a methyl propanoid, if I have one molecule of a methyl propanoid, how many hydrogen atoms are there? 3, 4, 5, 6, 7, 8. So ratio is 1 is to 8. Like one methyl propanoid gives 8 hydrogen. But I have how many moles are there? I have 0.5 moles of methyl propanoid. So how many hydrogen should be there? X. I will cross multiply. How many moles of hydrogen I'll get? I'll get 4 moles of hydrogen atoms. But I need the total number of the particles. So if I need the total number of particles, I will multiply by Avogadro's constant. So what I will do, this 4 moles are there. I'll multiply by 6.02 exponent 23. So 4 multiplied by 6.02 exponent 23, that will give us how many hydrogen atoms are there in this molecule of methyl propanoid. So first, from the mass, we got the moles of methyl propanoid, and using its formula, we'll know how one molecule give 8 hydrogen. So if there are 0.5 moles, this should give X hydrogen moles. It means it will give 4 hydrogen moles. And from moles of hydrogen, we just multiplied by the Avogadro's constant. We got the number of moles of hydrogen. Is it clear?
Yes, sir.
Yes, sir.
Then continuing the discussion of the mock, this is set 3. The nitrile chloride NO2Cl react with nitric oxide in a forward exothermic reaction. The reaction can reach an equilibrium. What is meant by the term equilibrium in a reversible reaction? You can use your mic, chat, or screen annotation to answer. In a closed system, that's very good. Who wrote the closed system? Rate of forward is equals to rate of backward and no change in concentration. But this is a very good term that you use in a closed system, because in an open system, when the system is open, like reactant or a product can be lost, then the rate of we cannot never reach an equilibrium in an open system. So in a closed system, the rate of forward equals to rate of backward, and there is no change in concentration. Explain why increasing a temperature increases the rate of reaction. So again, the same structure answer: higher temperature, more energy, greater kinetic energy, more successful collision, and greater number of the particles with energy more than activation. So this is a structure answer, and almost every past paper you will see such question. State and explain the effect, if any, on increasing a temperature. The reaction was exothermic, as I mentioned already. And if I increase the temperature, where the equilibrium will shift, right or left? So it should shift towards the left hand side, because I will say the forward reaction is exothermic. State and explain the effect, if any, on decreasing the pressure. on the equilibrium. So what is decreasing the pressure on equilibrium position? If when we compare the moles here, we have 1 mole of a gas, 1 mole, total 2 moles. Here we have 1 mole of a gas and 1 mole, 2 moles. So because we have equal number of moles of the gas, so there is no effect of the pressure on equilibrium. So you'll mention, but specify, don't say only equal moles, but you should complete the sentence equal moles of the gas in reactant and product, or equal moles of the gas in the reactant and product, so that the concentration, the pressure will not affect the equilibrium. Pressure only affects the equilibrium if we have different number of moles of gas. What if this was a question? Let's say this was a solid example. This was solid. Then what will happen when I count the moles? I will consider this as 1 mole. And this is two, these are 2 moles. So if I increase the pressure in this case, so we will ignore the solid. When we compare the effect of the pressure, we always check for the gas. So if I increase the pressure, equilibrium shift towards side of less moles. Because the gases can be compressed, gases, the pressure can be affected, but solid cannot be compressed, liquid cannot be compressed. So gases are compressible. That's why we always look for the moles of the gas. So sometime maybe you see an equation in which you find that the substance looks same, but you have to check the moles of the gas specifically. Next, we have a nitrosyl chloride is there, NOCl is a gas at room temperature. So there's a double bond between the nitrogen and oxygen. So there will be 2 electron pairs, and there will single bond between carbon and chlorine and nitrogen. And we have nitrogen belongs to group 5. So group 5 share 3 and unshared will be 2. Oxygen belongs to group 6. So it will share 2 and unshared will be 4. And chlorine belongs to group 7. So it will have one more thing I found, look, you're not supposed to make a key. Yeah, this is a dot and a cross diagram. No need to make the key. Look, the rule is that no need to make this key. So what you will do, if you are using, let's say you started with a dot, you started the oxygen with the dot. So the nitrogen will be cross, alternate. And then the chlorine, again, it will be a dot. That is why it is called dot and cross diagram. The nitrosyl chloride has a boiling point -6. Why? Because weak intermolecular, it's a covalent mention. When you refer, yes, weak intermolecular force, first thing refer, it is a covalent compound. It is a covalent compound, so it will have a weak intermolecular force. So small amount of energy is needed to separate the molecules from each other. What is the chemical test? Will the chemical test be? Yes, the chemical test will be given in paper 6. Paper 4 you have to memorize. Paper 6 I will provide that table. The qualitative analysis table will be given. You don't have to. So in the question, copper 2 sulfate solution was electrolyzed using an apparatus shown. Draw an arrow on the diagram to show a direction of the movement of electrons. The movement of electron always move away from a negative terminal or electrode, or it can attract it towards the positive terminal of the battery. You can refer that as A. Draw an arrow on the diagram, show movement of positive ions. Positive ions, this is not the right direction. The positive ions, because this is a negative electrode or a cathode, the positive ions are always attracted towards cathode. So this will be the right direction for. So you have to represent from a negative terminal, electrons will move out, and towards the positive terminal, electrons will move. And the movement of the positive ions are attracted towards the cathode. Oxygen was formed at the anode and the copper was formed at cathode. Ionic half equation is there. Why this reaction is oxidation? Always, whenever there's a question about oxidation or reduction, it should always be in terms of electron. And remember the term oil rig, that oxidation is a loss and the reduction is gain. So explain why the reaction is oxidation, because it is a loss of electron. Write an ionic half equation for formation of the copper at cathode. So copper ions are there. They are attracted towards the. So we have a copper ions. Copper is 2 plus. It will take 2 electron and it will form a copper atom. This change is called reduction. And can we say gain of oxygen or loss of? No, always whenever there is a question about oxidation or reduction, always write the definition in terms of electron. Don't use the term oxygen. The copper ion gains electron, turn into copper atom. So electrolysis was repeated using a copper electrodes in place of the carbon. So we are using a copper electrode. Explain what happened to the masses of the anode and the cathode. So this is made up of a copper. This is also made up of a copper. Electrolyte is a copper sulfate. So when copper ion will move towards the cathode, it will stick to the cathode, ion turn into atom. So the mass will increase for a cathode. And to overcome this change, the copper atom will turn into copper ion by loss of electron. So mass of anode will decrease. So anode mass decrease because the copper atom turn into copper ion. And mass of a cathode will increase because the copper ion turn into copper atom. The question is about extraction of iron from its ore using a blast furnace. In the blast furnace, the coke burns in oxygen to produce heat energy and the carbon dioxide. How this carbon dioxide converted into carbon monoxide in the blast furnace? So carbon dioxide reacted with more, like carbon dioxide is there, reacted with coke to produce carbon monoxide. The calcium carbonate added to a blast furnace decomposes to form a calcium oxide, and calcium oxide remove silicon 4 oxide impurities from iron in a neutralization reaction. Write a chemical equation and why it is a neutralization. So what is the chemical equation? A calcium oxide is a metal oxide or a basic oxide, and silicon oxide is a non-metal oxide, which is also an acidic oxide. So when acidic oxide reacted with a basic oxide, it will form a salt. So why specifically we call that as a neutralization reaction? Because the calcium oxide is a base or a basic oxide and silicon 4 oxide is an acidic oxide. So acid is reacting with a base. If they ask in exam, define the term neutralization. The term neutralization refers to when acid react with a base to form salt, specifically water. If you say salt and water, that's fine. But in this case, we have acidic oxide and a basic oxides are there. That's why we also call this as a neutralization. Like they remove their properties. One is acidic, one is alkaline. The main impurity of the iron in iron obtained in the blast furnace is a carbon. So why must the high level of a carbon be lowered before iron become useful material? Because if a greater percentage of the carbon is present in the iron, that this iron cannot be malleable, it can deform easily or break down easily, or we use the term brittle. Like when you hammer, it will just break down, crack, instead of malleable, because the most of the metal should be malleable or ductile, so we can use it for different purpose. But if it contain a high percentage of a carbon, it will be hard and rigid, or a brittle, you can also say that it will break down without deforming. And how is the carbon is removed? So how we remove the carbon? So in a basic oxygen furnace, the molten iron, use the term molten iron, is reacted with oxygen. So when a molten iron reacted with oxygen, oxygen reacted with the carbon to give off carbon dioxide. So react with oxygen at a high temperature, or oxygen is blown through the molten iron. Zinc is extracted from its ore. The ore contains zinc sulfide, which is roasted in air to produce a zinc oxide and sulfur dioxide. Zinc is then obtained from a zinc oxide using a blast furnace. Give a name of the ore that contains zinc sulfide. So we call zinc blende.
Zinc blended.
Write a chemical equation for a reaction that take place when zinc sulfide is roasted. So zinc sulfide is there and it is reacted with air to form a zinc oxide plus sulfur dioxide. Then why sulfur dioxide should not be released into the atmosphere? So what is the adverse effect of the sulfur dioxide? Sulfur dioxide is an acidic oxide which can mix with a moisture or a water vapor in the atmosphere, which leads to an acid rain and can damage the stonework or the building or the statues. And it can also cause affect the marine, can kill fish, can affect the plants as well. So one mark is for mentioning that it will mix with water and form an acid rain. And then as a result of the acid rain, it can damage the stonework or the building, statues. The temperature inside the furnace in the zinc is about 1000. The table gives some information about substances in the blast furnace in which the zinc is extracted. Use the data in the table. Explain why zinc obtained does not contain a high level of impurities of silicon dioxide and carbon. So if you compare because the furnace temperature is 1000, so at 1000 zinc will be a gas, but at 1000 silicon dioxide will be solid. And at 1000 carbon, because it's sublime, means like convert directly from solid to gas. So at 1000 the carbon is also solid. So what will happen, because the temperature of the furnace is higher than the boiling point of a zinc, so zinc will be vapor, like it will be vaporized at 1000. So zinc will be vapor and then it condenses. In the last part, two reasons we need, like, or you can explain the acid rain and what are the effects of the acid rain. The last part. And in paper 6, when we are writing experiment, whenever we wash the crystal with water, we should also add a mixture to remove water. No, when we can only wash the crystals of insoluble substance. Soluble crystals, if a salt is soluble, we never wash the soluble salt. Because if you try to wash the soluble salt, it will dissolve. So you never wash the soluble salt, we always wash the insoluble salt. This question is about the moles. A student heated 10 grams of sample of a barium carbonate until it was fully decomposed. Calculate the number of moles of barium carbonate that the student used. Moles equal mass in gram over molar mass. So mass in gram is 10. And the molar mass of a barium carbonate, you have to use a periodic table. Mass of a barium is, I guess, 131. Plus carbon is 12. Times like it is 1, and plus oxygen is 16 times 3, 48. So 48 plus 12, 60, 60 plus 137, 197. So it will be 10 divided by 197. How many moles of a barium carbonate we'll get? The moles of the barium carbonate 0.0. 5. Okay. Then calculate the volume of a carbon dioxide produced at room temperature and pressure in dm cube. So first, using a barium carbonate and a carbon dioxide, as you can clearly see, the mole, it's of 1 mark. The mole ratio is 1 is to 1. Like 1 mole gives 1 mole of a carbon dioxide. So if I have 0.05 moles, how many moles of carbon dioxide? X. So I'll get the same moles and then multiply by the molar volume, which is 24. So I'll get the volume in dm3. The student add 2 grams of a barium oxide produced to water. Like this barium oxide is produced, he added this to water. Calculate the mass of a barium hydroxide that can be made from 2 gram of a barium oxide. So here we can use a ratio of the mass. If the mass is needed and a mass is given, we can use the ratio of the mass. What is the mass of a barium oxide? Barium is 131 and oxygen is 16. So this will be 131 plus 16. It will be 147. So this total mass of a barium oxide is 147. What is the mass of a barium hydroxide? It's given 171. So if 147 is there, it will give 171. Yes, if question is of 1 mark, you can directly write the answer. Working is not having any marks here. Okay. It's specifically for a moles question. How you work out the answer does not matter. So you can also write the answer. Okay. So 147 is giving 171. In the question, how much we have? In the question, we have to. Okay, it was 137, right? Right. I thought 131. So it is 153. So this is 153 is giving 171 because 137 plus 16. So if we have 2 grams, so this will be X. Cross multiply. How much we got? The mass of a barium hydroxide. 2.24 grams. Okay. So 2.24 grams of a barium hydroxide is produced. Now, look how we got this answer. The question is student added 2 grams of a barium oxide, like he had 2 grams of barium oxide. We want to find how much barium hydroxide will be, calculate the mass of a barium hydroxide that could be made. Like how much barium hydroxide could be made from 2 grams of a barium oxide. So when I write the mass of a barium oxide according to the periodic table using their masses, so 137 plus 16, so it was 153. So 153 makes 171. If I was having 153 grams of a barium oxide, it will give 171. So if I have 2 grams, then this will be X. Cross multiply. So that was, when we use the ratio, it was giving 2.24. The next is in part C, 1.5 grams 1.5 grams of a barium hydroxide was dissolved in water. The total volume of the solution is 100 cm cube and 25 cm cube is used. Like we were having 1.5 grams here of a barium hydroxide and this was having a total volume one point five and we have 100 cm cube of a barium hydroxide. And from this barium hydroxide, how much sample we took out? We only took out 25 cm cube. So we took out only 25 cm cube of a barium hydroxide. And then we titrated with a hydrochloric acid. So we fill the burette with a hydrochloric acid. We fill the burette with HCl. And how much HCl was used? 18.75 cm cube. So we use 18.75 cm cube. That's a volume of HCl. And this is a volume of a barium hydroxide which was used for the reaction. Now the question is, calculate how many moles of a barium hydroxide are there in 25 cm cube portion. First, I will find how many moles are there in this 100 cm cube. So how many moles are there in 100 cm cube? Moles equal mass in gram over molar mass. So mass in gram is 1.5. And what about the molar mass of a barium hydroxide? It's already given 171. So 1.5 divided by 171. What's the answer? 1.5 divided by 171. What we got? 8.77 exponent minus 3. Okay. So we got 8.77 exponent minus 3. These are the moles, but these are the moles in 100 cm cube. We did not take 100 cm cube. How much we took? We only took 25 out of 100. So if we were having a 100 cm cube of a barium hydroxide solution, it was having 8.77 exponent minus 3. But we only took 25 for our reaction. So 25 will have x. Cross multiply. So 25 into 8.77 exponent minus 3 divided by 100. Or you can also do like divided by 4. 8.77 divided by 4 can also be done. So what's the answer? 8.77 exponent minus 3 divided by 4. So 2.19 exponent minus 3. Yes, I'll explain. Look, if you read the question, we were having a 1.5 grams and 100 cm cube. So we were having the total volume of this solution was 100 centimeter cube. And how much barium hydroxide was there in this 100 cm cube? We were having 1.5 grams. And from this 100 cm cube for a reaction, we took only 25 for the reaction. So 25 cm cube of a barium hydroxide is taken for a reaction with hydrochloric acid. So the question is, how many moles are there in 25? First, I'll find the moles in 1.5. How to get the moles in 1.5? Moles equal mass in gram divided by molar mass. So when we divide, we got 8.77 exponent minus 3. But these are the moles in 100. But I just took only 25 cm cube out of 100. So if the 100 cm cube contain how many moles? It contain 8.77. If 100 cm cube contain 8.77 exponent minus 3. So if I have, I took only 25. So how many moles should be there? X. We'll cross multiply. So how many moles we got? 2.19 exponent minus 3. So that's how we got the moles in 25. Is it clear? How we'll know? We have to take a ratio. Cross multiplication. Moles question, if you are not able to use a formula, because here I cannot use a formula. When I use a formula, I can only get 100, but I need in 25. So definitely I have to take a ratio. Now the calculate the concentration of a hydrochloric acid. So how much is a hydrochloric acid? First, you need the moles of volume is there for hydrochloric acid. If you need a concentration, you need moles and you need volume. Volume is there, but we need the moles of hydrochloric acid. How to get the moles of hydrochloric acid? We work out the moles of barium hydroxide. So the ratio between a barium hydroxide and the hydrochloric acid is 1:2. So if we have 2.19 exponent minus 3, so this will be x cross multiply. It will be 4.38 into 10 to the power minus 3. That's the moles of hydrochloric acid. We got the moles and the volume of hydrochloric acid was 18.75. We'll divide it by 1000, so 0. 0.01875. So this will give us the concentration in moles per decimeter cube. What's the answer? 4 exponent 4.38 exponent minus 3 divided by uh, 0.01875. What's the concentration now? 0.23. Do I always have to answer a standard form or no? It's not necessary. You can the moles question you can write in decimal. So 0.27 moles per dm cube. What is the answer for A1? A1 was moles of barium carbonate. You have to just divide by the molar mass. 10 divided by 197. In question 7, draw a circle around one repeat unit. Look, some student did like this. This is not the one repeat unit. You have to include all. This is one repeat unit. So you have to draw circle around the two carbon atoms, the first two carbon atom, including their branches. The structure of a monomer. So we draw the same structure. Just make a double bond between the two carbon atoms. Aqueous bromine is added to both polymer and monomer. With a polymer does not contain a double bond, so no change is there. But with a monomer, what will happen? It contain a double bond, so it will decolorize. With monomer, decolorizes. The diagram shows a part of a structure of a condensation polymer. Look, when both side, this is C double bonded with O and both side amine is there, means this is a structure of a polyamide. How if it was a protein, then what will the difference? If protein was there, then one side of a group will be amine. If it was a protein, then one side amine group will be there, another side carboxylic acid. That's how we can distinguish. So one side of the structure will be amine, another side will be a carboxylic acid. On a diagram, circle one repeat unit. So one repeat unit we have to circle. So what we should circle? The unit which contain the amine and the carboxylic. Which include, no, that is not the repeat unit. Like the structures start to repeat, you have to include this as well. This is not the correct. Where the structures start to repeat. Yeah, this, because the structure, if you circle this one and you circle the other one, you'll see that what is there inside these two circles is identical. Polyamide polymer which contain amide linkage we call polyamide. So nylon is an example of polyamide. It's a polymer which contain amide or a peptide linkage. Draw structure of the two monomers. So whenever we want to draw a monomer here, just what we will do, if we want to draw a monomer here, so what we will do, we'll separate this one. This will have OH is there because a carboxylic acid, and this will have amine is there, NH is there. Then hydrolysis is there for a compound. We have a carbon, hydrogen, and oxygen. Carbon is 34.61, hydrogen is 3.85, and oxygen is 61.54. Divide by atomic mass. So we divide this by 12, we divide this by 1, and we divide this by 16. This is 6 1 ion. I put 6. So 34.61, 3.85, and 61.65. Divide by smallest value and divide by atomic mass, then divide by the smallest value, and then take the simplest ratio in a whole number. And what additional information we need to calculate a molecular formula? So we need the molecular mass. Molecular mass is needed whenever we need the empirical molecular formula, we need the molecular mass. Okay. So the steps for finding the steps whenever you need the empirical formula, the step is that the step number 1, you divide it by the relative atomic mass. Step number 2, you divide by the smallest value in the combination. And step number 3, you will take a simplest ratio in a whole number. So simplest ratio, to take a simplest ratio, you will either no, not rounding off, because it's not always done a rounding off. It should be a relative. I deducted the marks for the student, those who wrote only molecular mass. You should use the right term is relative molecular mass. Relative molecular mass. Okay. That's the right term. And in B3, what we have to do, we just have to break down this. This is one part of a molecule and this is another part of a molecule. We just have to break down and draw the monomer. The C double bonded with O part will have a carboxylic group, and the NH part will have, it's a amine group. So we just have to work out the two monomers from the structure of polymer. And shade, because this is shaded, so this should be shaded and this should be unshaded.